As we continue with the different steps on the animal feed manufacturing diagram, in this particular case, I'm going to be showing grinding, which pretty much means particle size reduction. Keep in mind that in some parts of the world, they have either pre-grinded, that is what is shown here, where you grind some of the cereal grains and then batch them with the rest of the ingredients, or what is called post-grinding. That is actually when you batch all the ingredients and then you grind them all together to have a more uniform particle size. Each system will have its own advantages and disadvantages. Grinding is a process where we reduce particle size of all the different feed ingredients, mainly the cereal grains like corn. Grinding helps because as you reduce the particle size, there's a better absorption by the nutrients by the animal, which increases its digestibility. Also, when we think about the processing, reducing the particle size of the feed ingredients help it have a better mixing effect, meaning that the majority of the nutrients will be better distribution throughout the batch of a feed. At the same time, for all the thermal processing like pelleting and extrusion, when you have a smaller particle size, in essence, those processes will become more efficient because the particles will bind better together, which improves its own pellet quality. In the feed manufacturing industry, there's two main equipments that are actually used for particle size reduction or grinding. The hammer mill, that is the one here you see on your left, and then the roller mill, that is the one you see here in the diagram on your right. There's also other equipments out there like a jet mill and a pin mill, but the most common ones are these two that I just mentioned, hammer mill and the roller mill. Going to the specific equipment, we're going to start talking about hammer mills. Hammer mill is probably the most common equipment to reduce particle size of grains and other type of feed ingredients. You usually will have a shaft that has connected to a motor either by direct coupling or by pulleys and belts, and in the shaft it will be connected to a rotor. The rotor will have a set of pins that come where the hammers are connected. The way that a hammer mill actually grinds or reduces the particles is by the form of attrition. Okay, that means that the overall process will involve grain falling from one side as when it comes into the chamber of grinding of the hammer mill. It gets impacted by the hammers as it rotates, and then as the hammers keep going down, it will form the part of attrition, which is pretty much cutting the particles and push them through the screen. The screen can have different type of hole size or diameter size that will be directly related to the particle size that we want to have. When we look about the rotor of a hammer mill, the location of the hammers usually comes with 4 sets of rows of hammers, depending on the design. But usually what is important to know at this point is that if you have a row of hammers, opposite to it should have the same number and weight of the hammers in order to keep that rotor balanced. The same goes from right to left or left to right. The number of hammers will depend on the design of the hammer mill and its capacity. The other equipment that is very popular to see in the feed manufacturing industry, as I said earlier, is the roller mills. Roller mills consist of 2 pairs, or in some cases even 3 pairs of rolls that have different functions as the grain flows from top to bottom. The rolls usually rotate one faster than the other in each pair in order to create an effect of cutting. And that's the way they actually reduce their particle size. It is very important that those rolls have a specific configuration on its surface in order to create that cut effect. The number of pairs of rolls will depend also on how small you want to go on that particle size. What is important to know at this point is that the first set of rolls, as you see here, will actually break the grain into smaller particle size. Then the next pair will reduce it, and if there's a third pair, we'll reduce it even more to a smaller particle size. The feeding system of the roller mill set is very important because you need to distribute grains or any product you're grinding throughout the whole length of those set of rolls. As we continue looking at all the different steps or processes on the animal feed manufacturing diagram, the next one is the batching process. This step of batching, what involves is actually where we pull all the different feed ingredients in different proportions in order to align them with the requirements of the animal feed diet. Those ingredients, when they're in storage, they could be in hoppers, metal silos, flat warehouse, or they could also be on bags, and then the operator will have to empty it out into a hopper with a receiving pit. They are proportionally distributed, and then they come into the scale system where they are weighted into the different specifications that the diet requires. After the batching process, as you see here in the diagram, is the mixing step. The mixing system is the process where all the different feed ingredients, either in solid or liquid, are mixed together or blended together in order to distribute them uniformly throughout that batch. The batch size will depend a lot on the requirements of your production. The important thing to know when mixing is that it needs to have the shortest possible mixing time in order to produce efficiency on your processing, and the ingredients should not be damaged. After the batching and mixing, it is very important to know that you have different options on what to do next on your feed mill process. If you're just producing mash feed, that is just pretty much ground ingredients, then you just pretty much go to the loadout section. You could stay in storage or go directly into transportation, either in bulk or in bags. If you're producing any of the thermal processing afterwards, after mixing, they will go into the pelleting or the extrusion process. Following, we'll be putting a little bit more emphasis on the pelleting process. The pelleting process is a process where all the feed ingredients are agglomerated and compressed in order to densify it and form pellets where all the feed ingredients are all together. It has different advantages depending on the different perspectives as you see it. It will produce less feed waste because there's no dust up to a point up in the environment. Then, of course, the animal will reduce its feed selection. Keep in mind that certain animals, including the chickens, will pick the different type of particles in the feed if it's in mash form. But if they see them in pellets, they will not see them that easily. Also, since in the pelleting process there is some cooking of the starches and some of the other ingredients, then it becomes a little bit more digestible for the animals. So that actually helps them to improve feed efficiency. At the same time, since we put the feed ingredients through a specific higher temperature through the conditioning process, then they will degrade some of the microorganisms that could be present through the feed ingredients, therefore helping to keep the animals safer. At the same time, since the product is all the feed ingredients are compressed, the density of the pellets will increase, of the feed itself, that actually help us to have a more efficient way when we're handling, storing, and of course also during transportation. In the pellet conditioning process, that is the first step as feed enters the pellet mill itself, is the process where all the feed ingredients are exposed to steam. Steam is one of the most efficient ways to transfer heat and moisture into the feed ingredients. The overall goal of the pellet conditioning is to start cooking the outer surface of those particles on the feed ingredients with the goal that they actually start gelatinizing and transforming itself so they could actually bind better with other particles on the same feed. So that is part of the goal of the overall pellet conditioning, to help start cooking the feed ingredients, help them to bind better, so after the next process, when it goes through the roll and die, they will bind better and then improve the pellet quality. After the pellet conditioning, that is here in the top part of the picture that you see, the feed ingredients that are now hot and humid will go through what we call the roll and die, that is in the pelleting chamber. There, the set of rolls, as you can see here in the diagram, will push the feed in mash form through the different holes of the die, so they get compressed and densified and comes in different sizes depending on the diameter of that hole on the pellet die, and then of course also with different lengths depending on the overall distance that is between the surface of that pellet die and the exit. There's no additional cooking due to the friction, but its overall goal is to densify the product to create those pellets. After pelleting, since we transfer heat and moisture into the mash feed to create those pellets, then we have to cool them down in order to go into handling or storage or transportation. So that's where we go on this animal feed manufacturing diagram to the next step, that is the cooling of the pellets. As we mentioned, pellet cooling is the process where we actually take out the hot temperature that the pellets have absorbed as the mash feed went through the conditioner in the pelleting system and the pellets were created in the pelleting chamber. It uses ambient air in order to go through the pellet mass that is inside the equipment. As you go through there, that ambient air will absorb that heat that came from the steam, and it will increase its volume, acting more as a dryer. So during the pellet cooling process, that hot air will also absorb a couple of points of moisture. The goal in pellet cooling is take out the heat from the pellets and also all the moisture or the majority of the moisture that was added during the pellet conditioning. There's different type of pellet cooling systems, but the most common now these days that you see in the feed industry is the Conifer cooler, that is this picture you see in the lower right hand corner of your screen. After that process, it is very important to also measure pellet quality by taking those pellets and then going through the different equipments that are to measure pellet quality. Pellet quality is usually the ability for the pellets to not break. The more they break, the less quality they will have. So it is very important knowing that pellet cooling plays a key role in terms of pellet quality. As we continue seeing the different steps on this animal feed manufacturing diagram, after pellet cooling, for those who are making feed for chickens, for broilers, then you need to have what is called the crumbling. Pellet crumbling is a process where we actually break the pellet into smaller parts in order to them to be easy for the smaller chickens or the baby chicks to eat them because their beak doesn't have enough space to eat the bigger pellets. Making smaller pellets is also another option, but it tends to be a little bit more costly and it reduces the efficiency of the overall pellet machine. The size of those crumbles will depend on the chicken age. Also, very important in pellet crumbling to know that there has to be a specific corrugation or surface texture on those rolls in order to just break the pellets into smaller pieces without crushing them into a mash. This concludes part 2 of Overview of Feed Manufacturing. Please continue with part 3.